नमस्ते बच्चों, कैसा है हालचाल। माई सेल्फ है डॉक्टर अशोक कुमार। हमने पिछले वीडियो तो बनाए थे इंजीनियरिंग स्टूडेंट्स के बच्चे के लिए। वी हैव डन द वीडियोस ऑन इंजीनियरिंग स्टूडेंट लाइक स्ट्रेंथ ऑफ मटेरियल्स and design of machine elements. Around 5 to 6 it is there in the YouTube channel. Please see my YouTube channel and subscribe my channel. Please like the videos and subscribe it. And today we are going to make on the physics 11th class Neet exam, that is called work, power, energy. This topic we will discuss because it is more important for 11th class students for studying the Neet exam, so that they can go for medical as well as for engineering purpose. So basically क्या होता है, basically what is work, power, energy? They are three interrelated terms: work, energy and power. What is work? Work होता है, say work is nothing but you are doing some plowing work in the field. Farmer is doing some plowing work in the field, and some in the construction work. Some person is taking bricks and doing some work. That is one type of work. So we have the work can be done by different person in different way, or we can say the number of hours done by person differs. Some person can do 16 hours of work, some person can do work 8 hours of work. Example, you take Narendra Modi, he will work more than around 20 hours of work, so that he is leading the country. So these are the different examples given on work, power and energy. Now suppose if we take the basic definition of work, how do you define a work? Work is defined as work. हम define करेंगे. We'll define the work. What is work? Work is done by a force. Work is done by force, right? Work is done by force on the body over a certain distance. So this is what how over a certain distance. So this is what how you are defined the work. It means if you want to work any work on the object, that object should move at certain distance. Then only you can say the work is done by the object, or you can say the person. Now if you take mathematician definition of work we can define W equal to F into D, where W is the work done by the object or the person, F is the force which is acting on the object, and D is the displacement of the body which is moving. So this is what how we can define the work. So now we have a small doubt in what is work, whether it is a scalar quantity or the vector quantity. Usually work is a scalar quantity, that is important. Work is scalar quantity, right? You know already what is scalar quantity and vector quantity. Scalar is only having what we call the magnitude, right? If you have vector, it is having both magnitude and direction, right? So work is a scalar quantity. Now SI unit of work is, SI unit is important. SI unit of work is usually we say as a Newton meter, right? Newton meter or joule. So you can use this what we call the SI unit of work. In the CGS system is different, MK system is different. So SI unit of work is taken as Newton meter or the joule. Now how do you define a joule now? So this is about the terms. Now you can define the joule, that is the unit we are using for the work. Now how do you define a joule in SI unit? Joule, very simple, joule. So when a force of 1 Newton displaces a body through a distance of 1 meter, displaces through a distance 1 meter along the direction of force, along the direction of force is force, then work is said to done by 1 joule. Then work is said to be done by 1 joule. So this is what how you can define a 1 joule. So I'll repeat once again. You can see very clearly, when a force of 1 Newton displaces a body through a distance of 1 meter along the direction of force, then you are going to do work is said to be done by 1 joule. That's what how we can define. That's called Newton into meter. Newton is the force, meter is the displacement. We're displacing the body. Now this is what how the 1 joule can be defined. Now next we have Suppose we take a area on some work. This is what we defined previously. It is on the object. Now work for Fs curve. Work done by Fs curve. Work done by work done by Fs curve. You suppose you have an area is given. How do you calculate the work done? So let's say this is a curve. This is a rectangular body is there. Curve is there. Right? You are going to calculate. Now this body, the force is acting like this. Is a F is a force and S is the here. This is the what we call the displacement. Here the B. This is what A, B, C. This is the what you are going to calculate area under the work. Now I will mark it like this. You want to calculate work done under this area. Right? Work is you are going to calculate work under this area. Now this is what point S1 displacement and S2. Now I want to calculate the work done by this area Fs curve. Now do you calculate? Simple. Work done you can say, right? Work done is equal to is the area you take, area under curve, area under curve multiply by what? Area under curve multiply by displacement along the axis. This is the displacement axis. This is the force axis. Right? This is the displacement axis. Displacement axis. Now what is the area of rectangle? You know already. Area AB BC into AB. Right? AB into BC. Now I will write AB into, or you can say work equal to BC. What is BC? BC into, this is what going like this, area BC into AB, right? BC into. So what is BC? The displacement is the AB. AB is the force. AB is force. So take AB is the force. F. Displacement. What is the displacement? This area under curve displacement is S2 minus S1. That is the displacement. So this is what how you can calculate. This is the displacement. This is the force. This is what the work done is calculated for area under a curve, or you can say for a rectangular box. It is called as Fs curve. Now I want to calculate the total work done by multiple forces. If the number of forces is more than one, how do you calculate the work done? Let us take an example of work done by a number of forces. Right? Let us take work done for, so work done for number of forces. If the net force, if the number of forces are more, we can take F1, right, plus F2 arrow mark, plus you have F3, right, arrow mark. So these are number of forces more, displacement is S. Is the S displacement, right? So the net force is given by F1 plus F2 plus F3, number of forces you have done multiplied by the net displacement. So net work done is a sum of all the work done by forces acting on a particle. So this is what how we can calculate the work done for more if the forces are more than one. So this is what we discussed about the work. Next we will move on to the energy. Energy is an important parameter next in the physics. Now energy, right? Fine. So what is energy? Now energy is the ability or capacity to do the work. Energy is, it is the ability, it is the ability to or is ability or capacity to do work. So this is what how we can say energy. Without energy you cannot work, right? We need some energy. If you are eating, some energy will come, you can do the work. The greater the amount of energy you have, you can do more work on the body. Greater the work it will be able to do. Energy is cause for doing the work. You need energy to do the work, right? The work is the effect on the, you can say work is an effect. So if you move on to which type of what we call the scalar quantity or vector quantity, energy is again a scalar quantity. Is having only what we call scalar quantity, right? Now we will next switch on to what is the unit for energy. Before going there, what are the example for energy? We have different types of energy. Mechanical energy is there, right? We have light energy is there. You can see the light energy. We have heat energy, right? We have sound energy. We have electrical energy. We have nuclear energy. By using nuclear, you can prepare nuclear bombs, right? That is nuclear energy. Mechanical energy example will be your engine, IC engine, internal combustion engine, where the energy, heat energy can be converted into a mechanical energy by the combustion of fuel and air inside the engine. That is called heat energy. 1 type of heat energy is converted to mechanical energy, which horsepower can be used to run your vehicle. Your vehicle starts running because of the mechanical energy. Sound energy, myself is sound energy. Example you take, my vibrations are coming from the sound, vocal cord, Because of the sound, the vibration is come. That is called sound energy. Light energy, you can see in your home. Without light, you will not see any. You cannot use without light. You cannot make it bright in the room. That is called light energy, right? Heat energy already discussed. Sound energy, electrical energy. You need electrical energy. More of the electrical power plants are there in the industry. Electrical power plants where you can use the electrical energy, right? Nuclear energy. We need a nuclear power isotopes, right? They are using for preparing your nuclear power plants, right? They are using in nuclear power. So these are different forms of energy. Now in this energy we have mechanical energy. Is a very rare. We are using more mechanical energy. We have two types of mechanical energy, right? One is called kinetic energy, kinetic, right? Energy. One more is your second one is potential energy. So we will discuss these two things. Then we'll go for next. What is kinetic energy? One is potential. These two terms are much used in physics and everywhere in your the future things. Now, in the kinetic energy, we'll discuss examples. I will give, and we'll move on to potential energy. What is kinetic energy? This kinetic energy, right, is given by half mv square. That's my equation. Half mv square, where m is the mass of the body, v is the velocity of the body, right? Example of which type of energy you can see in day-to-day life. What are the examples of kinetic energy? A vehicle in motion. A vehicle is motion because all wheels, 4 wheels are running. It is a kinetic energy, right? Water flowing in a river. Most of the water flowing in a river is a kinetic energy. A bullet fired from the gun, kinetic energy. Or using a gun for firing, we get what we call the kinetic energy of the. You are using kinetic energy. We have a bird flying. You have a kinetic energy. Bird is rotating. Almost all. If it's a rotating part, you can get the kinetic energy. In the fan example, in the room, we are using kinetic energy. So all rotating components will get much. It should have some motion with some velocity, and the body should have some mass. Then you can say it is a kinetic energy is associated with the material, or you can say the body. Now, second one is we have potential energy. Very important, we can say potential energy. Usually we call it is also called a stored energy. It is stored energy in an object or body. Since stored energy, the body has a potential to do the work. Is called potential energy. It is a stored energy. It is a stored energy in the body. Stored energy in a body to do the work. Fine. This is important. So it is usually given by mgh. Potential energy is given by height, right? It's called mgh. M is the mass of the body, g is the gravity, h is the height of the body, right? So this is what how examples I will give. Water stored in a dam. What is the potential energy? You can say some water is stored in the dam. Example, Kaveri Dam is there, Mysore, right? A very big dam. If you take water is stored, that stored energy is utilized for different what we call the farmers. A bent bow possesses the potential energy. Bent bow, anyway, you can take the bow which is bent, right? Which is called potential energy. A flying bird possesses. A flying bird, you have flying bird, which is also having potential energy. So one more example I will give you. So if you take a spring mass system also, it is having some potential energy. Suppose if you take a fixed mass here, this is what your mass is there here. The spring is connected, right? This is m. For this system, you can calculate the potential energy, right? And kinetic energy also. Potential energy is stored in the spring. When the mass displaces down, within displacement x dot is velocity, x double dot is acceleration, right? When it is stored, it is coming down. Some amount of energy will be stored in the spring. That is called potential energy. You can calculate such type of system in the vibrational system. You can calculate your potential energy as well as the kinetic energy of the system. So these are the examples I have given for the kinetic energy. So last one is we are dealing with. The last one is power. What is power? So simple term, we have power. The average power is defined as the ratio of work to the total time. So whenever you are rating your rate, if you divide by time, power will come. Same work you are doing, but how much time you are taking to do that work, divided by time, will come power. Power is the rate of doing a work divided by time. That is called power, right? So P average is given by P average, right? Work total divided by T time total. Time total So it is given by delta K by delta T, delta K by delta T. Now you can see what you can say the ratio of total work done by that person or that object divided by how much time it takes to do that work. If you divide that, you will get the power, average power of the body. So what is the SI unit of power? SI unit of power, SI unit of power is, you can say watt. Usually we are using watt as a unit for the power, watt, or it is also called as joule second. Use joule second. You can use joule second or watt for power. It is also a scalar part. So I hope all the students understood. So in the next video we will discuss about some problems on the work power energy. So thanks, goodbye, have a nice day, good health. Thank you, one and all. Thank you, one and all. Thank you.